Hey guys, just want to do a quick video because you're all sliding in my DMs about who won. And although I'm going to say who won, it doesn't really, I'm not trying to say with this test, this is the company you should buy from, this is the best intake ever made, and all the others are shit. I'm not saying that. I think we all know by now that the stock intake needs work. And pretty much any design that you see out there is going to perform better. If we take a stock intake, you got like 440 millimeter holes. You got a 60 millimeter hole here, which is basically the area of two of these. You can see its limitations. They tried to have equal length runners. I don't know if that's important. Not something I can really test. But they didn't have the real estate, so they started cranking them. And, that on a normally aspirated engine, generally you can say air doesn't like to move, doesn't like to turn greater than 7 degrees. It will and it has to, of course, but it doesn't like to. So this first runner actually performs well. Even though it's got to do this 90-degree turn, it performs well because it's straight. When the valve opens, it's got all this air already sitting there waiting for it, and it doesn't have much of a crank here. These guys are really cranked, and I think the reason 951s started looking for new intake designs, I think was through racing, basically. And this shows you how my test isn't the end all and be all of tests. When this engine's pumping and valves are opening and closing and the turbo's pounding air in here, I mean, air has mass. It has inertia, so it's gonna want to shoot straight. And that's why this cylinder tended to go lean and, sort of high-end racing applications. Not something you really see on the street, but, endurance racing and stuff like that, yeah. You're going to notice that this cylinder goes lean, and they got problems with detonation and stuff. So, flow benching this isn't going to tell you that kind of real-world stuff. But it just gives you some numbers you can work with and kind of see what the intake is doing, and see how we can improve things. So, when you test a stock one, this intake does pretty good. This one, not so good. I think the third one is generally the worst. Second or third is the worst. It sounds like a steam whistle. It's unbearably loud because there's so much resonance and so many angles. You can just hear the thing just vibrating and fighting itself. It doesn't matter how much kind of pressure you jam in there. It hits a wall and starts dropping off. The last runner is usually not too bad just because of this. It's kind of straight through at least until that point. But the air running past the webbing there, it's deafening. You got to wear ear protection when you're pounding this thing. And so you can see down there how tight the webbing is there. And so that's your stock one. When you start modifying the stock one, the things you do is usually this one's got deported. I didn't test it because my head is not deported, but this will go quite nicely with a matching head. The intakes have been enlarged here, so it's more of a funnel. You always want to have, you don't want to have equal length pipes. You want to have it wider going to narrow. This one could have been maybe the webbing could have been brought back a bit more, but still, this thing's going to perform nicely, especially with a matching head. And we got one here going to a stock 40 mil, but the webbing's really been taken back, and you can see, I mean, I can almost see right down to there. Nice job there. The webbing's taken back, and these sort of intakes are really opened up. And then you got this guy, which really sort of focus on I think that one of the most important aspects of the intake is this throttle body hole is just too small, you know, for the size of intakes you have. This one really shines because it's got a nice open throttle. It's probably, I think, 5 millimeters over, and the webbing's taken right back. Really big runners, and this one goes to enlarged. I had to clay it just to get it to work on mine. I could have tested that one, but we just didn't want any clay getting sucked into the machine, so we just took a chance with this one, and worked out fine. Got some numbers from it, but again, on a matching head, this thing will shine. So I just wanted to say that, you know, like, yeah, I'm gonna say this one pulled the most CFMs, but anyone that knows stuff about, you know, flow bench testing, it's you know, there's three things that's gonna get you horsepower, and that's airspeed, airspeed, and airspeed. And CFM is an airspeed, so we just have to take this test into consideration for what it is, and it's just some interesting things to look at. And you know, we haven't seen anything like this done like this before, and you know, maybe we'll do some other testing in the future. You know, maybe I could put a motor on the dyno. I don't know, but that's it takes a lot of time and trying to get schedules to match up. And thanks to all the guys that sent me these intakes, and we'll release the numbers and see what the next step is. But anyway, so thanks a lot, and I'll talk to you guys later. So.